Okay, here we go for example 3 for trig sub. So in this video we're going to be doing the integral of square root x squared plus 9 over x to the fourth. And for this one, I notice it looks like tangent, but I don't 100% have 1 plus x squared, I have 9 plus x squared. However, if instead of x here, I had not tangent theta, but 3 tangent theta, then notice that x squared becomes 9 tan squared, and then when I add the 9, I can factor it out, and it ends up working out. So that's the substitution I'm going to use. So let's actually do it. Then dx, I'm going to do that substitution, 3 secant squared theta d theta, and then I have the integral of 9 tangent squared theta plus 9 over 3 to the fourth is 3 squared times 3 squared, which is 81 tangent to the fourth of theta. And then dx, I can write 3 secant squared theta d theta. Now I can just do simplify, simplify, simplify. I get the integral of 9 and 9 can come out to make 3. 3 and 3 make 9, and 9 over 81 puts a 9 down here. So overall I have a 9th as my constants. I have the square root of tangent, in fact I'll write it out, tangent squared theta plus 1 over tangent to the fourth theta times secant squared theta d theta, 1/9 integral, tan squared plus 1 is secant squared. Secant squared under the square root just turns into secant, and then I have 2 more of them there, so I've got 3 total. Okay, so now I have secants and tangents, but I actually don't have them multiplied, which is usually what I did in the trig integrals video. That's the last section, but they're actually being divided this time. What I'm going to end up doing is I'm going to just see what happens when I change everything into sines and cosines. So secant cubed is 1 over cosine cubed, and then I divide by sine to the fourth over cosine to the fourth. Once I do that, I get 1/9, 1 over cosine cubed times cosine to the fourth over sine to the fourth. Here's my d theta. Then I see these 3 cancel. I just left with 1 up here. Now I've got cosine over sine to the fourth. And this is exactly what I'm wanting for a u sub. If I let u equal sine theta, then cosine theta d theta just becomes du. So then I can rewrite this as 1 over 9th integral 1 over u to the fourth. And then I can just do a power rule. So 1/9, the integral of u to the minus 4 becomes u to the minus 3 over minus 3, which is minus 1 over 3u cubed. So I have integral of u to the minus 4, which is minus 1, and then I have a 1/9 out there, over 3u cubed. That leaves me with a 27 out front, and then I just can backtrack. So that's all of the integration done with. Now I just have to backtrack and sub everything back in. So I'm going to draw my arrow down here, minus 1 over 27, u is sine theta, 1 over sine cubed theta, not d theta, plus c. And now I have to figure out what sine theta is from my original substitution. So I'm going to write down what my original substitution was. X is 3 tan theta. So I'm going to have to solve for tan theta and then draw out a triangle to see what happens. So x over 3 is tan theta. And I can just figure out what sine is. A tangent is opposite over adjacent. So if theta is here in my right angle, tangent is opposite over adjacent. That's my x over 3. Then I have on my hypotenuse x squared plus 9 under the square root. That's just Pythagorean theorem. And then sine theta is opposite over hypotenuse. So sine theta is going to be opposite over hypotenuse. So I've got minus 1 over 27 times 1 over sine cubed. So I'm going to put in sine theta there. Cubed. Now I'll just simplify just a little bit. There's not too much I can do, but I can do a little bit. Minus 1 over 27 times. It's in the denominator, so I'm going to flip it. Raise it to the third power. And then I have minus 1 over 27. I'm just going to distribute that cube. There's not too much else I can do. I'll make it a 3 halves. And then x cubed plus c. And that's the final answer.